computer, right? Okay, guys. So I hope you guys very well. Neither. Okay, you are doing this your studies very well. Neither. Right. Okay. So new year, first session. I think this is your first class. Somebody's first classes. Neither. Right. Okay. Concentrate. I think 2 or 2.5 hours. I will conduct this session. So completely focus the all words what I'm going to tell here. Okay, so each and every words are very important, and believe yourself, end of the session you all can completely answer the any question from regarding these lessons. Okay, so this is a challenge for me and you, because little bit big topic we are going to cover within 2 or less than 2 hours or more than 2 hours, I don't know. Okay, however, we'll start, right? So okay, now let me share the screen, right? Hope you all guys having this cute with you, right? So I think you all having this cute with you, neither. Electrochemistry. So first lesson, first topic we are going to cover as a seminar in this year. So electrochemistry. So I shared a document already. So I think there is 5 pages, 5 or 4 pages. Okay, right. So this is the first page. Okay. So take the tute with you. Now we will move on to each and every topic we are going to cover. First, we are going to cover the topic electrochemical cells. Okay, right. I think you can see my screen and you can visualize this all the things neither, right? Okay, take the tute, and now we focus a little bit this topic regarding this topic. Okay, right. Now I will talk something about this topic. This is electro. Then next word is chemistry. Electrochemistry and cells. All right, I found 3 words to this topic, right? Now look at about this electro part. What is this electro? What is the meaning by this electro? Somebody know? If you know, you can answer anywhere. The chat is open for you guys. So anything, any silly questions you can ask. So have a fun with this session. Not fun with me. Okay, fun with this unit and this session. Okay, so anybody can ask anything, right? Okay, electro. Electro means, I will explain, that is some physics term. Okay, but it related to chemistry as well. Electro means, I tell it's a electricity wage there. Electricity, right? Electricity or electric or electricity. Okay, this is I usually pronounce this electro mean electricity. Right? It's a chemical. There's some chemical process. Cells. The chemical, some reactions, chemical things or chemical things, it produce electricity now. That cells we calling as a electrochemical cells. What is the thing we should know here? Electricity, spelling mistakes. Electricity, okay, it should be produced by some chemical. So electricity produced by some chemical reactions. The main thing is that chemical producing electricity, all of this structure we call as a cell. Okay, so chemical things, they are going to produce the electricity, and that structure, okay, that object we're calling as a cell. So this is a electrochemical cell. Okay, now I hope you guys got some idea about this electrochemical cells. Okay, we will move on to the definition. Okay, take your tubes, and there is a definitions there. So read the definition. Okay, right. I will erase these things and we will move on to the definition part, and I will go a little bit fast today because limited time. We have to cover this topic, but don't worry, I will not miss any topic here. I will fully cover the session, right? Okay, now we will move on to the definitions. I hope you all guys can see my screen. So definition: convert the chemical energy stored in the chemicals into electrical energy. All right. That's the things we should understand here. What is the term here? Important terms: convert chemical energy, right? So you guys can write down here. So take the tube pen, put these things here, right? This is the definition now. In this side, you can write down something, put a star mark or anything. So chemical energy. What is the energy, Puta? Chemical energy. Okay. So chemical energy converted to which energy? Electrical energy. So, right, okay. So, chemical energy converted to electrical energy. So, that structure, that process, where that process happening, we are calling that is a electrochemical cells. Okay, right. Now, first definition is complete. Now, where are they located, these things? Right. So, here, if you have some space, where we use these things, where we use these cells, right? Electrochemical cells. Okay. So examples, one is toy cars. Okay, you all have some, neither most of you guys having some siblings with you, neither, so they have some toys. It contains these cells, battery, right? Electrochemical cell, right? Then electrical toys, then electrical torches, okay? Then mobile phone. Yes, all of our mobile phone containing batteries. So the common name is battery, okay? So common name battery, but inside that, what mechanism happen? Electrical energy converted in chemical energy converted into the electrical energy. So this convert happen inside the battery. So we are use the term electrochemical cells. The common name is the battery. Okay, you guys can pronounce it as a battery. So sometimes they sell dry cells, right? Calculators, computers, all sort of things contain this electrochemical cells. Okay, so all these examples are where we use these batteries or cells, right? Now we have a practical. Okay, we will move on to that practical, right? Then only you will understand what is going to happening here. Now you have some sort of knowledge about what is the things happening inside, basically, right? So right, basically what is happening inside the battery, right? So convert the chemical energy to electrical energy. Now activity 12.11 in your textbook, we have an activity name like 12.11. So it's a reaction between zinc and H2SO4, sulfuric acid. All right. Now we will move on to that image. Okay, you have an image in this side. Okay, right. Okay, focus on this image and we will discuss what's going to happen in here. Right. Now, this is the zinc plate. So this is the zinc plate. Okay, label it. Label. Right. That's why I chose this digital method. Otherwise, a little bit difficult. And I have to draw these things, and then erase and again draw. Little difficult, but now it's smart. Right. Okay. What is this? Now go into reaction between zinc plus H2SO4. So this liquid should be H2SO4. Right. When the zinc plate contact with this sulfuric acid or H2SO4, what is your observation? What you can observe? Observations. What are the observations? What you can observe here? Tell me something. Now, you all guys learn this lesson. I hope you all learn in your school. Our camera is not clear.
Gas bubbles liberate.
Yes, okay. Right. Okay. If any problem is there in the screen or in the camera, tell me. I hope little bit dark because there's a light source is coming back me. So my face and myself a little bit dark. Yeah, so don't worry about. You guys can see the images and you guys see the text. So then understand, right? Okay. Gas bubble, yes, good. One told here, gas bubbles. All right, something bubbles, go out. Another thing, zinc plate. What happened to the zinc plate?
Dissolves, deplete.
Yes, depletion or dissolve. Okay, right. Now, I will go a little bit deep and zoom. I will zoom this more, right, a little bit large picture. It's a big picture, right? That's why I choose this digital thing. Right? Digital board this is not a actual digital board. This is made by myself. Label made by Dr.Sir. Right? Because I used to project and so many things and prepare this screen. Okay, right. Right. This is not a perfect one. Okay. Right. Now, this is a zinc plate. This is a zinc plate. Okay. In the zinc plate, there is small, what is this? Zinc atoms. We know every metal, they made by atoms. They are made by atoms. Okay. They are made by atoms. All right. What is here? Atoms. Right. Okay. I draw few atoms. If I try to draw more atoms, you have to wait until 12 a.m. or 1 a.m. 2 a.m. Right. Okay. Just enough. Now, this is the some area I draw zinc atoms. Okay. These all are zinc. Right. Because this is a zinc plate. So it contains zinc atoms. Okay. This is a little bit zoom picture. If you want to draw this in your tute, you can use any spaces available here, or you can use any sticky note or any paper. Then you can attach with your tute. Okay, so these are the zinc atoms. Right. The surrounding. What is the surrounding? H2SO4, sulfuric acid. So usually the sulfuric acid contains two ions. What are the two type of ions? H plus and SO4 2 minus. So here I will draw some H plus ions are there. So you can see this, right? Some H plus ions are there. And at the same time, in this solution, SO4 2 minus ions as well present. Okay. right? So SO4 2 minus present, right? Now there is some business going to happen there. Business එකක් යන්න යන්නේ. What's happening? Zinc, they are going to give rise their electron and they are going to remove their electron. They are wishing to go inside this solution. Okay? ඒක හරියට මෙහෙම. අර trip යනකොට එහෙම when you guys go to the trip to Anuradhapura, Polonnaruwa, නේද? So those areas there are several lakes නේ. Several lakes. So usually if you are visit to there, you can observe something when you are cross the lake or you are walking around the lakes. You can observe something. Some people coming, the village people, they are coming and they are going to bath. They are going to take a bath and they are coming and take their things, keep their things in front of the any rock or any places around the lake. And they are going to jump the lake. හරි. يعني ආපු ගමන් එහෙමම පනින්නේ නෑ. දුම් පිටින් එහෙම මේ එහෙම නාන්න එහෙම පොෂ් නෑ. right? ඒ එහෙම පොෂ්. එහෙම පොෂ් නාන තැන් තියෙනවනේ දැන් swimming pool වල නේද? දුම් පිටින් නාන්න එහෙම. But this village people, they are very poor people නේද? So they are going to remove their clothes. කොහොමනේ මේ remove their some sort of clothes and they are going to jump. Right? That things happening here. Right? හරි. මේ Think is now going to have a bath. Think very loud to jump into this solution, right? Now this sink, I chose this sink atom, right? It's going to jump, but unfortunately, it want to remove its cloth. It want to remove its cloth. So when it's remove its cloth, it becomes sink 2 plus. Not they are removing clothes, it removing electron. Not only one electron, it removes 2 electrons. But the thing is, they have to keep their electrons on this metal plate. Metal plate, okay? They keep their electrons and they are jump into this solution. Other zinc atoms also doing the same mechanism. So that zinc molecules go into the solution and they are keeping their 2 electrons. Okay, right? This zinc also go in there. So zinc 2 plus, it's become zinc 2 plus and 2 electrons there. What now happening? Now you can observe something in this metal plate. This area is going to empty. Why? There is no atom. Why? The atom is become iron and it jump onto the solution. Now in this region there is a no one zinc atom. It's jump. Here also there is empty area. So now you can observe zinc is dissolving, but another business should be happen here, right? මොකද්ද? Anyway, දැන් මෙහෙම හිතන්නකෝ. Now zinc also take a bath in this solution. H plus also take a bath in the solution. Okay. Now someone want to return to home. What's the process? So you want to go to home. You have to get up and you have to again wear your clothes and you have to go. Now, not the zinc is coming to take the cloth. H plus coming and ask the cloth of zinc. Zinc, you are taking bath. So I want to go out. So can you give your clothes, please? Give your clothes. Okay, zinc 2 plus telling. Okay, I put my clothes on the outside area, so you can go and pick up that. Now this 2H plus, they can manage their dress with zinc. So they come and take these 2 electrons and they are moving out from this place as a H2. What is as a H2? Now you have some idea, right? What happened? 2 things happen. One happened here, zinc, it's become zinc 2 plus So these are the solid one. So this is become aqueous, and so that's why it's become into the solution and remove the 2 electron, right? So another process happened here. H plus, 2H plus came here, take 2 electron, okay? They are take 2 electrons and they become H2, right? So H plus is a aqueous, so H2 is a gas. So these two business happen here. So what is the business happen here? H plus, 2H plus come and take the electrons of zinc. Zinc already removed that 2 electron and kept on the this zinc metal part, then it jump into the solution. So H plus come and take the 2 electrons, and there are now two type of reactions. What is one reaction? Removing electron. One reactions gain or taken that electron. Now we have two type of reactions. One reactions we call as a oxidation. Wherever the electrons removing, we call it as a oxidation. Got your point? Right. This is oxidation reaction, right? So this is oxidation reaction. Now, what is this one? That is the one, reduction reactions. Okay. So okay, now you all got the idea. So if you got the idea, please raise your hands, or if you have any doubt, you can ask anytime. Okay, right. Okay, hope you guys got the idea, right? Now we move on to the theory part. Okay, right. Now, what are the observation? Zinc metal, what they dissolve, and H plus, they are becoming form the H2, and so that's we can observe as a gas bubble liberate here, right? Okay. Now, okay. Now, if you want, you can sketch these things in the image I already put into a tune. So you can mark these things, or you can write down the observations on the given area, right? So we will move on to here, but I want to tell more detail again after finishing this practical. Before moving to the next practical, I want to tell something regarding this practical, right? Okay. We'll move on to the observation part. Okay, right. Now, sorry. Observation. What is the observation here? You can write down two observation. That is zinc plate, dissolved, and another one is H2 gas. Yes, very good. H2 gas, or we can't tell exactly like a H2. We can tell gas bubble liberated. Okay, right. Write down with me. Yeah. Okay. Now, reason. What is the reason? What is the reason here? What business happened here? Zinc. What happened here? Zinc. Okay. Oxidized and oxidized and form zinc 2 plus. Okay, so this is a zinc oxidized and form zinc 2 plus. Then another reason is H plus. Okay, H plus gain electron and form H2 gas. All right, that is the reason zinc oxidize and form zinc 2 plus. Okay, H plus gain electrons and form H2 gas. So we can tell H plus gain electron means there is a reduction. Okay, that is a reduction. So H plus reduced and form H2 gas, and zinc oxidize and form zinc 2 plus. That is the reason for this observation. That's why the zinc plate dissolve and we observe the gas bubble liberated here. Okay, right. Hope you guys clear. Right. Now we will move on to the half reactions. So you can write down here oxidation reaction and reduction reaction separately. Okay, so write down to the, you have a space here. So what is the oxidation reaction? Zinc, put the state, the solid, and zinc 2 plus aqueous and 2 electron, right? Then what is the reduction reaction? 2H plus aqueous, gain 2 electron and form H2 gas. Right. Okay. Now you can write down the overall reaction here. So zinc H plus. So if you are take it as a 1, so if you are take this as a 2, so 1 plus 2 you can write down here. Overall reaction 1 plus 2. So you can write down, but make sure both electrons, amount of the electron should be same. So here 2 electron, now here 2 electron, right? Okay, now we can multiple. We can take the sum. So 2H plus here, then so it automatically cancel the electrons. So zinc 2 plus and so this is gas, right? So we finished one practical neither, right? I think my screen almost clear neither, right? Okay, good. Now we got these things. Okay, I hope you guys got this idea, right? Now we are going to see how we going to produce electricity using this type of reaction. Some oxidation reactions, some reduction reactions, we saw the overall reactions, how these type of reactions help us to produce electricity. How is possible? How it's happened? Now right now I want to yes, I want to again move on to the image, right? Right, okay. Now again we come and focus here, right? This is a previous practical name. So I thought some business happen here. What business? Electron business. So some people kept electron on top of this metal plate and they are jump into the solution. So who are the people going to jump here? Zinc 2 plus. Zinc, it's becoming zinc 2 plus. It's keep 2 electron here and jump here. Okay, right. Again, H plus in the solution is come here and it will take some electrons. So 2H plus, they are coming together and take 2 electrons, 1, 2, and they are form H2. Okay, right. So this is the business happen here. What is the business? Electron business. So this electron business is the reason for the electricity, produce the electricity, right? Right. Produce the current here, right? Now this H plus take in electron. Whose electron? That electron is already belong to the zinc. Zinc remove that electrode and it's jump into the solution, and H plus is coming and taking that electron, right? So, but the thing is, this business is happening one place, in the same place. This business happening in this same place. Business. But I want to now facilitate where electron remove karne ka. Whoever going to remove the electron or whoever going to do the oxidation reduction, oxidation reaction, I facilitate them to do this reaction in one place, and the another business, another partner who coming to take the thing, it electrons, that center I'm going to put another location. So I'm going to do this business in two different locations. So two different things happening here. Some people removing the electron, so some people taking the electrons. Why I am going to facilitate two? Why I am going to give two location for this two different business, because some people coming here to buy, some people coming here to sell. Zinc usually selling his electrons, and H plus is come and taking or buying the electrons. Okay, that's the business happening here. But I'm going to give two location. Zinc, you have to remove your electron in one place. Then in between there should be a transporter, right? So we will see in a different manner, right? Now I ask the zinc, you have a option, you can remove your electrons. Okay, so he's loving to remove these electrons, and he's becoming zinc 2 plus. Now this zinc metal is becoming zinc 2 plus. Okay, right. Now he's storing his electrons are here. This is the zinc metal plate doing this business here. Here only one process is happening. What is the process is? Here we are simply telling this is a selling. Vikunana vitarai, not buying. We are arranging another place. Okay, so this is the place buy. So it's look like a main. One place for selling, one place for buying. So in between these two locations, we have to transport this product. What is the product? It's electrons. So electrons are the products. So we have to transport from here to here. We have to transport these products from here to here. Now we use a conductor. We are using a conductor to transport this electron. Okay, from here to here. Okay, Buddha. I hope you guys gaining this knowledge, neither. If you have any doubt, you can ask in time. So these two electrons, these electrons, whatever the electrons on top of this zinc plate, because of this zinc becoming zinc 2 plus, and they are jumping into the solution, and they are kept their electrons on top of this zinc plate. Then we have to transport this electron to wherever this electrons going to buy someone. Now these electrons are going through this conductor. Okay, I will draw this conductor in a little bit clear. Okay, this is a conductor. What's happening through this conductor? That electron is going. They are traveling, coming to this area, and in this area, someone come and buy these electrons. Okay, they are going to buy this electron. So selling is happening one end, buying is happening one end. So in between, these electrons are traveling. Okay, so now we are facilitated to travel this electron. Now what happened here? We facilitate this electron to travel. Okay, Putta, wherever electrons traveling through a conductor. Okay, clearly listen again. Wherever electron travel through the conductor, that is the place we can have electricity. So wherever electron flow or traveling electron through the metal conductor. Okay, so moving electron flow we can tell as a electricity or current. Now our purpose is fulfilled. Neither. What's our purpose? We need to produce the electricity through a chemical reaction. Okay. Previously also that chemical reactions happen, but not produce the electricity. Why? The business is happening in the same location. Now we separate, selling one place, buying one place. So someone produce electron, they are doing that job in one place. Whoever come and take the electron or buying the electron, that job is done in a separate place. So in between these two locations, that electron should be transported. The transportation of electron, that electron flow, that is producing the electric energy. Okay, so that is the electric energy we can use as a current. That is the one we are using for mobile phones, we are using for toys, we are using everywhere, right? Okay, are you guys clear now? Do you have any doubts? Okay, I hope you got idea, neither. Right. Okay, now we will move on to the next practical. We have another practical. So I got this all practical images from your textbooks. Okay, so no need to draw again and again. So all the printed images are there. Right. Now we will move on to the activity 12.12. That is the practical we are going to conduct using a sink, hopper, and H2SO4. Right. Now we move on to the image. They are given an image. Okay. Right. So this image, what they are telling here, we have two different locations. One I label as a sink. Okay, label it as a sink. Okay, right. So I will label it as a sink by using black pen. Blue pen is not clear neither. So this is a sink and this is the copper. This is a H2SO4 solution. Right. Now we will see what's happening here. Okay, please label this image. Right. Okay. Okay. Right. Now I will little bit zoom because I want to draw that distance. Okay. Right. Now you guys know these things. So this is a sink plate. Okay. So what's happening here? The sink, we have sink metal. So sink's metal plate now it's containing zinc atoms. So it's containing so much of zinc atoms. What happened? These zinc atoms, they jump onto the solution. All right, this atom now it's jump onto the solution. It's forming zinc 2 plus. Okay, and keep the electrons. Okay, it's keeping 2 electrons now. Then again another zinc metal atom, it's jump into the solution as a zinc 2 plus, then keeping the 2 electrons. Okay, so all of these zinc atoms now they are jump into the solution as a zinc 2 plus. So we can observe this zinc again in this practical. What happened? This zinc becoming dissolved. Yes, Puta. What happened here? This zincs become dissolved. Correct? Zinc become dissolved. So that zinc, that electrons are in a one place. So this is the place where having these electrons. Okay, right. Now we have to do another business. Someone selling the electron and someone should buy that. Right. Who are going to buy? This is a sulfuric solution. is have a H2SO4. Okay, so what are the things available here? H plus ions. H plus ion in this solution, right? And also SO4 2 minus as well. But it's not useful here. H plus ions, they are coming and they are hoping to buy these electrons, but they are not going to that end. They know that place is not allowing to buy because that is the only place selling. Okay, so that is the only place production. Selling that is the production area, but they are not going to customers directly cannot go and buy there because that product should be transport and it should be come to the market. මේක තමයි නිකන් production එක කරන තැන. එතන production එක කරාට customers we can't directly go in to buy because that's a business නේ. Someone should get a benefit නම් ඔයා හිතන්නකෝ in our area අපේ I have seen several factories in our area. So they are producing something. Usually, you know that iPanel sheet, එහෙම හදනවා. But we cannot go and buy directly. Why? Because they are the one producing. Production එක වෙන්නේ එතන. But some transport නේද මේ සමහර transport කරන අය ඒවා අරගෙන ගිහිල්ලා එයාලගේ කඩවල් වලට දාගෙන then only we can buy that. So එතකොට තමයි කඩේ කෙනාට ලාභයක් හම්බෙන්නේ අර transport කරන අයට they will get some amount of money නේද? So most of the people can live through this business නේද? So එතකොට තමයි අනිත් අයට ඒ වාසියක් තියෙන්නේ. එතනම production එක කරලා එතනම විකුණු නෑ. ඒ ගන්න කෙනාටයි ඒ විකුණන කෙනාටයි විතරයි එතන වාසිය තියෙන්නේ. Right? So that's right නේ. Only business is only production here. So H plus cannot go and ask electron from there. So H plus going to this end. So this is the copper. Previously that one zinc. Now this is copper. Now they are going to ask this electron. So the electrons transporter through this conductor. Then that electron now coming to this side. Okay, that electrons are coming this side. So then H plus taking these electrons and they are doing same reduction reaction, but previously it occurs in a same place, now two different places. Okay, hope you guys got idea, right? Okay, now if you want you can draw this. Then this H plus come and take electrons. Okay, so they are taking electrons and they are producing H2. Okay, right. So this is happening here. Right now, okay, right. I don't know how many of you are awake either. This is a night time. Okay, අහගෙන ඉන්න ඕනේ. Usually I'm very tough teacher. Right. Line no right. Okay. Now you got the idea that electron flow, we are the electron producing here. Okay. So that electron flow going through this conductor from here to here. So that is we can observe by this ammeter. This is ammeter. So ammeter usually it has a this type of name. So we can observe this ammeter. What happened? What happened to this ammeter? It has a movement in this. Yes. Okay. Right. So now electron again coming to this end and again another business is happening here. Right. Now we will go and fill the right. Now we go and fill the observation. Okay. Observation electrochemical cells කියන එක මම දෙන්නම්. Okay, so write down the observations. What are the observation here? Then what happened in the zinc electrode and what happened in the copper electrode? So write down the reactions here. Okay, and observations. I will give 2 minutes. So now time to write down, because you guys want to write the exam neither. Right. How many of you finished? How many of you finish? If you're finished, please raise your hands. Yes, only one. What about others? What are the observation and what's happening in front of or around the zinc electrode and what happened around the copper electrode? Yes, okay. All right. Most of you guys finished neither. Right. Now, okay. So what is the observation? We have a ammeter. Okay. So first observation we can take ammeter pointer deflected. Okay, is deflected. Okay, right. Then second observation, zinc plate dissolved. Then another observation is gas bubble evolved. Right. Then right. What is the electrochemical cells කියලා තව චුට්ටෙන් ලියමු. Then zinc electrode එක ළඟ මොකක්ද උනේ? Zinc become zinc 2 plus and remove 2 electron. Okay, so that is solid and aqueous. Right. Now okay, copper electrode H plus 2H plus take 2 electrons and produce H2. That's gas. This is aqueous. Okay, right. Now we know electrochemical cell එකක් කියන්නේ මොකද්ද? එහෙනම් මොකද්ද? This is electrochemical cells. එහෙනම් මොකද්ද? Chemical energy converted into electric energy. Chemical energy converted into electric energy. Okay, that's the cells we are calling electrochemical cells. Okay, so electrochemical cells mean where කියලා දාගන්න පුළුවන්, where the chemical energy converted into electric energy. Right, that is the electrochemical cells කියන එක definition එක again we wrote. Right, now we have 2 electrodes. What is this electrodes? What are the electrodes? Electrodes කියන්නේ මොනවද මේකේ? The zinc plate and copper plate. Yes, correct. The zinc plate and copper plate are the electrode. Okay, right. So we can tell the metallic any metal or metal part or metal plate that dip in a solution, we can call as a electrode. Okay, there is a definition. So any metal plate dipped in a solution. All right, that is the one electrode. Ehnam metana we had two electrode. Why? We had zinc and copper. Okay, so zinc dipped in here, solution H2SO4, and copper. Okay, right. So we have two. One is the zinc electrode and another one copper electrode. So if you have where is my eraser? Here. Okay, if you have a space, enough space, example, any metal plate dipped in a solution, we call as a electrode. Examples here, we can write down zinc electrode and copper electrode. Okay, now zinc electrode we wrote the reaction, finished. Then copper electrode we wrote the reaction. But if you have enough spaces here, explain this reaction name. What is this? This is a oxidation reaction. Oxidation reaction. Then H plus, that is a reduction reaction. Okay, so zinc oxidation reaction and H plus reduction reaction. Okay, right. So you can write down those things. Now we are going to again right, electrode, any metal plate dipped in a solution, example zinc electrode and copper electrode here. And we should know another things. Okay, I will explain in next part. Okay, we should have two different electrode. We call one electrode as an anode, one electrode as a cathode. Okay, so electrode two types. Okay, so one is anode and one is cathode. Okay, right. Now we will move on to the next part. So before moving to the next part, here the electrode you can take another arrow and write down here. Okay, there are two type of electrodes. So one is anode, one is cathode. Okay, then another thing you can identify here, what is the reaction happen in the anode and what is the reaction happen in the cathode. So there are two type of electrodes here. So anode and cathode. So where the anode is the one oxidation reaction take place. Okay, where oxidation reaction take place. Okay, right, that is the one anode. Okay, then cathode. What is the cathode? Reduction. Electronic oxidation වෙනවා නම් another one is the one reduction reaction take place. Okay, so write down these things. So electrodes, two different electrode types. So one is the anode and cathode. So anode usually they have oxidation reactions, they are taking place oxidation reaction, and cathode the reduction reaction. Okay, right, finished. Okay, finish now. Please raise your hands. Okay, where are others? Are you guys sleeping? Right. Not sleeping either. Right. Good. Okay. Okay. Very good. Right. Daganda bear. Now we move on to the next part. Okay. Now, how we can identify the anode and cathode? Okay. Right. How we can identify the anode and cathode? Right. That is the next topic. Identify anode and cathode. Now we have one. Sorry, there's a problem. Okay. Identify the anode and cathode. So more reactive metal act as an anode. That is the important one. Take a highlight and highlight this word sentence. That is very important. Very important. So what is the thing we should understand here? More reactive metal. More reactive metal act as a anode. That is act as a anode. So less reactive na cathode dehna. So we it's only one thing you can memorize. Neither more reactive kena anode na, less reactive kena definitely should be cathode. Neither right? Okay, you can memorize only one. Then you can identify next other one. Neither right? So more reactive metal act as a anode. Okay, that is the simple one. Right now, before oxidation act anode, okay, I already given that things here neither. So reduction at cathode. So the space එකකුත් දීලා තියෙනවා. Right. Okay, and okay, more reactive metal act as anode. So oxidation at anode. Okay, highlight that word as well. Reduction at cathode. Then another space is here too. Okay, space is why I gave this space here. Yeah, you already given all the things, right? So okay, we can utilize this space. Okay, more reactive metal. Okay, act as anode. Act as anode, and that is the place oxidation reaction take place, where oxidation reaction take place. Okay, so this diagram now you can write here. More reactive metal act as an anode, and where the oxidation reaction take place. Okay, okay, right on. බලහින් ඉන්න එපා වැඩ. ගැම්මෙන් වැඩ කරනවා. So January 1st, new year 2026. නේද? Oh. Right. Okay, you finished. Right. Now, another thing you have to understand here. Anode and cathode. Again, they are given space. Cathode, that is as a positive. There is a positive terminal in the cell. Okay, then anode is a negative terminal. Okay, right. So anode is the one take place the oxidation reaction, that is becoming a negative one here, and cathode is the one becoming positive, and it is the place where reduction reaction take place. Right now, tell me, how we can identify the more reactive metal? More reactive it act as an anode. Yes, that is okay. More reactive act as an anode. But the thing is, who is going to more reactive here? How we can identify that? Who is the one going to more reactive here? For that, we can use this activity series. Right. So above that, I think you have a space here. Space right. For that, from that space, write down, okay, to identify the more reactive metal. To identify the more reactive metal, we can use activity series. Okay, to identify the more reactive metal, we can use activity series. Okay, right. Now, okay, we have an activity series here. Right. Now, I gave two different things here. Okay, so here from top to bottom there is an arrow, and bottom to top there is another arrow. So what happened from top to bottom? Reactivity. What happened to the reactivity? You know, guys, reactivity decrease. So less reactive. So chances to be cathode. So chances to be cathode. Okay. So reactivity decrease top to bottom. So decrease reactivity, more chances to be a cathode. Okay, right. From this end, what happened? Bottom to top, reactivity increase, chances to be a anode. Chances to be a anode. Okay, right. So fill that spaces. Okay, chances to be anode. Right. Now you guys got the idea, right? Now tell me in the previous cell we had two electrode. We had two electrode. One is the zinc, another one is the copper. Okay, then we connected them with the ammeter. Okay, we observe there is ammeter pointer deflection. Right. Now tell me what happened to this? Who is becoming anode and who is becoming cathode? Zinc or copper more reactive? So you can come and find out here. The zinc copper is here in the activity series. Zinc is here. Okay, so copper is here, zinc is here. Who is the one more topaz? Topper is the zinc. So zinc is the one here. Anode. Previous diagram. So anode and cathode is the one copper, right? Then we know, we can understand, we can identify anode is the place where oxidation happens. Oxidation unane tana, but the oxidation zinc become 2 plus ne. So cathode, that is the place reaction happen. Okay, right. So these are the two different things happen there. Okay, right. Now you guys have a activity. So you guys have a activity here. So let me erase the screen. Erase karne ka hari amount beda. All right. Okay. Okay. Now examples. I gave a few examples here, and there is a example 1 and 2 images. Focus this one, example 1. Ferrous and copper electrodes are there. So here ferrous and zinc electrodes are there. So you guys can find out who is the anode, who is the cathode in the example 1 and 2, and spaces are given here. Neither, right? Spaces are here to write down who is the anode, who is the cathode. Okay, so I will give 2 minutes and fill these things. Okay, so if you're finished, please raise your hands. Okay, only one finished or 2 finished. What about others? Okay, the simple one. Simple, very simple. You have to find out the more reactive one. For example, 1, ferrous and copper. Okay, so let's turn to the ferrous and copper now. Turn to the, yes, activity series. Find out where the ferrous and copper. Ferrous is in the top. Ferrous is the one top. So ferrous top, copper is here. So you know ferrous should be anode and copper should be cathode, because more copper is the anode. නේද? අර ඉස්කෝලෙත් මේ ක්ලාස් එකේදීත් මේ ටොපර් වෙන එකකින් නේද මාර ඇණයක් තියෙන අපිට. ඌ තමයි හැමදාම හෝම්වර්ක් මතක් කරන්නේ නේද? So toppers ලා හැමදාම ඇණයක්. නේද? toppers ලා ඇණයක් වෙනවා හැමදාම. So most top person comparing, whenever we are comparing two, the most toppest one is the anode. Okay? So ferrous is the one anode here. Okay, so not to write here, you can write down in the image as well, but you have another space, so write down there. So copper is the one cathode. So no need to write down the reactions here. Okay, so I'm not expecting that. So I am expecting here, find out the who is the anode and cathode. Okay, right. Now we finish that part, and another example here. There is the ferrous and zinc. So among the ferrous and zinc, to find out who is the one topper. Right, ferrous and zinc, you can find out ferrous is the one lowest and zinc is the one highest. Zinc is the highest one, so we can find out here zinc should be anode, ferrous should be cathode here, right? Okay, so this is for your understanding purpose only, right? For this is the one cathode. In this diagram, this is cathode, this is anode, right? Okay, now we finish only one page. We have 5 pages. Okay, right, we'll move on to the next part. So before that, I think you all got this idea, fully idea regarding this electrochemical cells, right? So I have some past paper questions, but I think today's we cannot discuss the past paper questions at the moment. Tomorrow or day after tomorrow, we'll discuss the questions regarding these lessons. Now turn to next page. Okay, we have electrolysis. Okay, we have electrolysis here. Before that, I'll give a little break for you guys. So take 5 to 10 minutes, 10 minutes break, and come back, refresh. Neither if you want to have a cup of tea or a cup of milk, so take a 10 minutes break and come back. I will do this part as well, electrolysis part as well. So then only we can finish this session. Okay, right. Have a cup of tea or coffee or have your dinner and come back after 10 minutes. Okay, so I am waiting here for your word. Okay, right. We will meet after 10 minutes. Bye bye. Okay, right. How many of you are back to the session? Please raise your hand. How many of you came back? Oh, some of you guys having dinner or coffee, right? Okay. Right, now we move on to the next part. Okay, so we finished electrochemical cells. We move on to the little bit different topic, electrolysis. So before that, before moving to the next topic, I have some advice for you guys. There is the one because you have exams in another 1 month time. So nowadays you are preparing for your exams. So number one duty is you have to do the papers. So these type of short notes. So if you want any short notes in any lesson in the science, I can provide the short notes and take that short note and highlight what are the important point, and please at the same time finish all MCQs, all SCQs, all essay questions regarding that topic. Then take another topic and do. Randomly you can choose, not in order manner. So whatever the lessons you love with, love more love, so you can take it first and you can finish them, then only move another topic and topic. Okay. So you have 9 subjects in it. So for that all 9 subjects, do that way, then only you will get in some kind of understanding regarding some units. Okay, right. So don't take too much of papers because time is limited now. So take a few papers, at least 5 papers now. Enough, neither. Last 5 years papers you can choose, right? So now we move on to the next part. Before going to next part, now I will move on to this activity 12.11. Okay, so in the top of your tube or short note, there is a 2 spaces, so only 2 practical images are there, so choose one. Okay, right. So we will discuss something here, right? Okay, now okay, all of you came back, ne? Right? Okay, now what is the things I am going to doing here? I will get a little bit zoom image. Okay, right. So I put some anode and cathode something here, right? Okay, so I will put here one positive terminal and negative terminal here. So that's positive terminal is connected to here. So this is the one positive end, positive terminal. Okay, right. Then here negative, so it's connected to the negative terminal. So this is the negative end, negative terminal, right? Okay, now in between this negative and positive terminal is connected to the battery. These are some sort of battery there. So okay, right. So it's connected to this one and it's connected to this one. Okay, these are 2 different electrodes. Okay, so you can collectively call them as electrode. Right, now this electrode, what happened, they are dipped in a solution, they are put into some solution. So now this is the practical. First we are going to apply some solution here. Okay, so we apply some solution and we look at about this ammeter deflation. Okay, so this is the ammeter, so label these things. So this is the ammeter, right? So usually in the ammeter, what we can see in the ammeter, usually the ammeter looks like this. So center, right? This is the ammeter, right? So in this ammeter, what we can look, if some solution, if we add some solution, sometime we are adding some solution, and there is a point depletion there. Okay, so deflection is there when we apply some sort of solution, but it is not for some solution. Why that? What is happening there? Inside that something should happen. So what's happened there? Why?
Presence and absence of mobile ions.
Right. Yes. That is the thing we discussed here. The electron business is happening in the cells. So there is a electron flow. Okay, this electron flow. So that electron flow coming here and they should go to here, coming here from negative terminal, and they should go to the positive. Okay, but in between no connection, no metallic connection, and the solution is there. So that solution should be helped to transport this current, making current එකක් or electron. The solution, if it is help or it is facilitate to transport the current through this solution, that type of solution we call as a electrolytes. Okay, that solutions we are usually called as a electrolytes. Okay, so electrolytes, what is the definitions here? Yes, liquid or a solution conducting electricity are referred as electrolytes. Okay, right. Now we draw one image. You take one image and label this all the things, and we are label this diagram. Then we are write down at the side you have, I think, few rules, neither few lines we can write down. Okay, electrolyte. Okay, right. Okay, then in the side you have some rules. Okay, and I given spaces, so write down these things. Liquid or a solution, liquid or solution conducting electricity are referred as a electrolyte, okay, right, are referred as electrolyte. Okay, then what is the observation here? When we apply the electrolyte in this setup, we can observe the ammeter, pointer, deflection. Okay, right. When we apply electrolyte in this setup, when we put electrolytes in this setup, we can observe pointer, ammeter, pointer. We can observe ammeter, pointer, deflection, because that solution facilitate to transport the electricity or current, okay. Simply that type of solution, whatever the solution facilitate to transport the current, okay, that are we are calling as a electrolytes. Okay, so what are the examples? What are the examples? Okay, examples for electrolytes. Right, so I think you finish all the rules, neither, right? Wherever, write down examples for electrolytes. Right, what are the examples? Few examples enough. Okay, one is acid and base. Okay, so aqueous acid aqueous acid. Example, HCl, H2SO4. Right. Then aqueous ionic compound. Aqueous ionic compounds. Aqueous solutions of ionic compound aqueous ionic compounds. Right. What are they? Yes, sodium chloride. Okay. Then copper sulfate. That are the aqueous ionic compounds. They have ability to transport the or facilitate to transport the current. Okay, right. Another one, fused sodium chloride or fused liquid ionic compound. We can tell fused, not the aqueous, fused, or we can tell liquid of ionic compound. Fused liquid of ionic compound. Example for that, fused sodium chloride. Sodium chloride. Okay, right. So that is enough for you guys. So not only the acids, we can write down acid and base. Okay, right. So bases also we can take as electrolyte. So fused ionic compounds and aqueous solutions of the ionic compounds, all of them having ions. That's why they have facilitate, they are facilitate to transport this current. Okay, so they can produce the ion. Okay, so usually if we take the solution and there are two terminals. Okay, so one terminal not connected to positive in the battery and another terminal is into the negative. Then here what happened, the sodium chloride we applied here. So what happened, this sodium is becoming sodium chloride becoming sodium plus and Cl minus. So this sodium plus can have and Cl minus have ability to take their electrons and do some activity here. Okay, so that is helping to transport this current throughout this circuit. Okay, so that circuit will be fulfilled due to these solutions. Okay, right. So these are the electrolytes. Now another same image is there. So we will label it as soon as possible. So this is again positive terminal and positive terminal. Then this is a negative terminal. Okay, so in between I am going to fill what is non-electrolyte. Okay, non-electrolyte. Okay, right. So let's complete the diagram. Non-electrolyte. Okay, Then you have a space on the right side in your tube. Okay, write down these things. Okay, a liquid or a solution, or liquid or a solution not conducting current, not conducting current, or we can tell electricity, not conduct the electricity, is called as non-electrolyte. They don't have ability to produce they don't have ability to produce ions for transport the electricity. Ions for transport the electricity. Right. So what are the examples? What are the examples? Pure water. Examples. One is pure water. Pure water have minimum amount of ions. So usually we call them as a no ions. Okay. So pure water. So that pure water don't have iron. So it cannot transport the electricity from this end to this end. So this circuit not going to fulfill, and ammeter point deflection we cannot see in here. Right. Another examples, organic compounds. Okay, right. What are the organic compounds? So organic compounds here, examples, petrol, kerosene, then paraffin. Okay, petrol, kerosene, paraffin. So those are the organic compounds. That organic compounds also not facilitate the electron transportation. Right. Okay. So we know now something regarding these things. Okay. Now we found out the simple theory. What is the simple theory? Some solutions have ability to transport the electricity. They have ability to transport the current from one end to another end. But some solutions, they don't have ability to transport the current. Okay. So who has the ability to transport? We call as electrolyte. Who don't have a ability to transport, we call them as a non-electrolytes. Okay, so we should know something, some examples for electrolytes and non-electrolytes. Okay, that can be asked in your MCQ questions. Okay, right. Now I'm going to give some MCQ questions. Okay, we'll see, but I want to share it in a screen. Okay, right. Let me share the MCQs. Okay, so if you guys have a MCQ with you, MCQ in your past paper box, okay, you can take them. Okay, right. So electrochemistry part. Okay, let me. Right. Okay. I think I have to share this. Okay, I will share the screen in the lab. Okay, right. So tell me guys the answer for this question. So this is the 2016 O level. Okay, so tell me the answer now. You have a time. You can read the question. Okay, which of the following statement is false regarding the electrochemical cells is given in the figure? So iron strips and copper strips. So find out which one is going to be a anode and which one is going to be cathode. So more reactive one, who is the more reactive, iron or copper? Which one is more reactive, iron or copper? Am I audible? So give me the answer. Yes. Some oh, okay. Some people send in the answers about others. Okay. Let me share the. So if I share this in the in this background, that will be easy, neither. Right. So here's that question. Okay, you guys find out the answer, ne? Right. Okay, I have to send the question paper to my. Okay, right. Yeah, few of you send the answers to the inbox. Okay, right. Yes, most of you guys telling third is false. Okay, third answer. Okay, let me share the question in the screen. Maybe back screen it will be easy for you guys. Okay, give me 1 minute. So it's uploading, right? Because I in the evening I plan to conduct this session because I had few works today, but suddenly I planned and put this session today, right? Okay, right. Now back screen. Okay, ready. Okay, this question is there, right? Okay, now we'll move on to one by one question. So first one, they ask about the false regarding this. So we have to find out iron strip is there and the copper strip is there. So which one is the more reactive? I can find out iron in the top. So this is the anode. Okay, more topper is the anode, more lowest one is the cathode. Okay, so this one is the cathode, right? Now we can find out anode is the one going to do the oxidation. So in the anode, what happened? Oxidations will be take place. Then in the cathode, what will happen? A reduction is going to take place, right? So what will happen here? Iron strip act as an anode. That's correct. Iron strips act as an anode. That's correct. The reduction reactions occur at the copper strips. Yes, copper is the one cathode. Cathode is the where reduction reaction take place. Then gas bubble evolved rapidly at the iron strips. No, gas bubble evolved mean what happened here in this solution H plus, they are going to take H plus should take 2 electrons and they produce H2 gas bubble. So this is the one reduction reaction. So it's take place around the copper strips, not in the iron strips. That wrong. Electron flow towards the copper strips across the external wires. So where the anode is there, iron. Iron is the one produce more electrons there. Then that electron is transported to copper through this wire. Okay, right. Now you got idea. Neither right. Okay. So this is the one example question, examination question in the 2016 O-level paper. So why is gas at the copper? Yes, gas at copper end is copper is the one lowest, the less reactive one. So copper is not involving in these reactions. In the solution, we have H plus ion. So that H plus ion go and take the that upcoming electrons. So H plus taking these 2 electrons and going producing H2. So copper is not involving in copper ion or copper metallic part or atoms, not involved in this business. Neither, right? Okay. So we will search if we have any other question. Okay, we'll see. So this is 2016. So find out where the 2016 question paper. So we have okay. Most of the questions are regarding the electrolysis, and we have a corrosion part as well in this part. So as a MCQ, we have this only this MCQ up to 2016. But I don't know what about the 2024 paper and 2023 paper, and we'll see next day. So we finished now up to this part. So we finished up to this level, but I will discuss these things, electrolysis and the definition and all this. Electrolysis part, we have 2 pages. So I hope it's better to do in another day, because if we finish in a half, it's very difficult to initiate again. So we didn't start the electrolysis part. So I will do in the next session. So as soon as possible, I will arrange it. Then we can do this second page, third page, and the fourth page also is regarding the electrolysis part, and electroplating also is coming under the electrolysis part. Okay, right. So all these things we can finish within another day. So today I taken more time to explain the basics thing. That's why I think we spend lots of time in theory discussions. So next week or next day, next class, we can discuss remaining part. So I need your feedbacks regarding today's session. So I don't know how many of you actively join or not. So how many of you get the benefit from this session. So I don't know that. So your feedback is very important for me to improve these sessions. So we will see next day and go. And before going to the sleep, take a textbook and again refer what I am telling and highlight what is the important point, and that will be keep in your memory until exams finish. Neither until finish no need permanent memory. Right? Okay. Right. We'll see. See you. Bye. Thank you for your joining, guys. And if it is useful, if you get something from this session, tell to your friends as well. So see you. Bye. Ta-ta.
Bye, sir. Thank you, sir. Good night.
Good night. Bye.